Hi, we're going to be talking about section 2.2, which is called graphs of functions. In the past, we have learned how to graph by plotting points. Today, we're going to also graph by plotting points, and we're also going to talk about something new that is called the end behavior. If I was to describe what the end behavior is with words, basically the end behavior is what happens to the graph at the end points of the graph. That's basically what we want. Okay, so let's go ahead and go over the first examples here. Okay, so as you can see, this is a power function, but this power function happens to be linear. And the reason why it's linear, it's because the degree of the variable is just 1. Okay, so let's go ahead and quickly make a t-table of values. Okay, when x is -2, and if I plug it into the equation right here, then if I plug it in, that will be a -2. Plug in a -1, my answer will give me an output of a -1. Input is 0, output is 0. Input is 1, output is 1. Input is 2, output is 2. Okay, now, when we do the graph, okay, now for this, I recommend you guys using a ruler, because the ruler will definitely help. Okay, so this is my -2. Here's my -2 also. I have this point, -1 and -1, 0, 0, 1 and 1, and then 2 and 2. You can definitely see that this is a line right here. Go ahead and go back and redraw it. Okay, what I care about is what happens at the endpoints of this graph. Okay, so you can think like this. I would like you to think like if I was to select very large X values. Okay, I started with something small like 1, and it gave me a positive number. Then I move on to 2, and it also gave me a positive number. But what if instead of selecting 1 and 2, I select a 10? I think I'm still going to get a larger Y value. What if I get 1,000? Well, my output is also going to be a very large value, which is 1,000. What if I select 1,000,000? Then my output is also going to be 1,000,000. All right. So now, how can I describe what I'm saying with words with symbols? Okay, so here we go. So then I'm going to say it like this. I'm going to say, look, as I select very large X values, that's what this means. As X is getting closer to infinity, and as we're getting very large X values, my Y values, my function, it's going to the positive infinity because this over here, it's large. That's what we call the end behavior. Another way to say it, for this class, you can also say, look, it rises to the right. Okay, it just goes up to the right. However, this rises to the right, it's not really the precise definition. Okay, now let's go ahead and move on to the next one. Look, this is a -2 over here, but what if I select a -10? This will also be like a -10 over here. But what if it's a -10,000? And that will be a -10,000. So then I'm going to say as X goes to the negative infinity, my Y values are going to the negative infinity as well. And this is what we call the end behavior. Now, on your homework, this will be on your homework on WebAssign. There are some problems where they're going to tell you, look, what happens as X is getting closer to infinity? Where is it going? Go ahead and tell me. And you have to write where it's taking you. Once again, later on when we do the graphs, you might not have to tell me, you just have to know where the endpoints are going to take you. So then in this case, it's going to drop to the left and it's going to rise to the right. And that will be fine as long as you know where it's going. but the correct answer will be this one that you see right here. Okay, let me go ahead and move on to number 2. We're going to do it the same way. You can see that this is a parabola. And for my parabola, I'm also going to make a t-table of values. -2, -1, 0, 1, and 2. By the way, everybody should know what the shape of this parabola is. But in case you have forgotten, this will be for practice. I'm going to input a -2 into that square. So then that would be a -2 squared. That would give me a 4. So this is a 4. Input a -1. -1 squared, that would give me a 1. Input the 0, that would be a 0. Input the 1, that would give me a 1. Input the 2, that would give me a 4. And let's go ahead and do the graph. And so then I can see that this is a -2. My graph, it's not drawn to scale. -1 and 1. 0, 0. 1 and 1. And then 2 and 4. And you guys, all of you guys, have seen these graphs before. This is the one that makes a huge shape. Okay. You can see right here that the endpoints, they both rise. So it rises to the left and it rises to the right. Now let's go ahead and describe that with words. So then we can say as x goes to the -infinity, let me go ahead and start with the -infinity. So if I'm going to select very large x negative values, I can see that it's going to the positive infinity. So then f of x is going to go to the positive infinity. As I select very large positive x values on the opposite direction, which is here, I can still see that it's also going to go to the positive infinity as well. So f of x will go to the infinity here, positive infinity. That's it. That would be the end behavior. And once again, the only thing I care about is what happens at the endpoints of the graph. Okay, so far I have given you 2 examples. I'm going to give you one more example right here. And you will do it the same way. We're going to make a t-table of values. By the way, this one's a cubic function. And the cubic function will behave in a different way. I had mentioned to you guys that I call this a snake graph because it looks like a snake when you're graphing it. Okay, we're going to do the same thing again. So -2, -1, 0, 1, and 2. Plug it in. So I'm going to plug in the -2 in here. And when I do, I get -2 to the 3rd power. That gives me a -8. Gonna plug in the -1. -1 to the 3rd power. That gives me a -1. Plug in the 0. You go ahead and do this and 1. Plug in the 1. Plug in the 2. Okay, then do the graph right here. Okay, at -2, I have a -8. So it's like about here. -1 and -1. 0 and 0. 1 and 1. Let me go ahead and make it a little bit better right here for my graph. It's like about here. 2 and 8. Okay, now let's go ahead and connect the points here. You can clearly see what's going to happen to the endpoints of this graph as well. it's going to drop to the left and it's going to rise to the right. And so now you just describe what you see. As x goes to the negative infinity, so very large negative x's, I can see these arrows going down. So then f of x will go to the negative infinity. Okay, as I select very large x's, positive x's, f of x will go to infinity. Okay, well, with that in mind, this is what you guys are going to be asked in the homework, just to describe that end behavior. I have given you 3 different examples here. And so hopefully these examples will help when you guys are doing your homework. Let's go ahead and move on to rational functions. For rational functions, we're going to do it the same way. Okay, now you have 2 different ones. Okay, I'm going to do this one first. Okay, so the first thing that I'm going to notice is that this is a fraction. And since this is a fraction, I gotta care about the restriction or the domain. We have talked about the restrictions in the domain also, okay? So in this particular case, my denominator, which happens to be my domain, cannot be equal to 0. Okay, so now it cannot be equal to, but I also wanna know how close can I get to 0 and can I still get a value? So let's make a t-table of values. And this is what I want. What I want to know is I want to get values that are close to 0 and then far away from 0. Okay, close to 0 and far away from 0. Okay, so let me go ahead and do my picture right here. So this is what I want. I want to know what happens as I get very close to this point right here, 0 right here. So I'm going to get large negatives. So let's go ahead and try a negative 10. And then I'm going to get something closer. Okay, so go ahead and say this is negative 10 right here. And then I'm going to go with, let's just say a negative 2. Let's go ahead and go with a negative 1. And you have to pick decimals because you got to get as close as you can to 0. You cannot stop at negative 1. Okay, so let's go ahead and go with negative 0.5. You can get something smaller if you want to. Okay, so you can see that I'm going to only do one side first, only the left side. So go ahead and plug in the negative 10. So I'm going to get this number and I'm going to plug it into the function. So that's going to give me a negative 1 over 10. Okay, but when you put it into the calculator, the negative 1 over 10, that's equal to a negative 0.1. Plug in the negative 2, that gives me a negative 1/2, which is equal to a negative 0.5. Okay, plug in the negative 1, that will be a negative 1 over 1, that will be equal to a negative 1. Plug in the negative 0.5, and that will be equal to a negative 2. Let's see, let me go ahead and select one more number. What about negative 0.1? So 1 divided by a negative 0.1, that should be equal to a negative 10. That gives me enough values for me to know where this is going. Okay, let me go ahead and erase this negative 10. I'm going to plot the points. So I have negative 10 and negative 0.1. So something very small. Negative 2. Let's go with negative 2. And that will be a negative 0.5. So let's go ahead and go with this point here. Negative 1 and a negative 1. So let's go ahead and go with here. Negative 0.5, so halfway, and a negative 2. And then something smaller, negative 0.1 and a negative 10. Something over here, yeah? But you kind of see where this is going. Let me go ahead and delete that. Okay, so here we go. You can clearly see what it's going to happen. It's never going to cross your x-axis right here. And it's never going to cross the y-axis over here either. We do have an end behavior as well, but this behavior, we're going to talk about it later on in Math 5A. We do say, look, what happens as x goes to negative infinity? As my x values are getting very large on the negative direction, we can actually see that we're getting closer and closer to a particular number, which happens to be your x-axis, which is 0 in this case. But not for Math 3, like we don't describe this type of behaviors for rational functions. Okay, I'm gonna do the same thing now to the right side of the same graph, okay? But I'm gonna go in the opposite direction. So now this is the negative. I'm gonna select everything positive. So 0.1, 0.5, 1, 2, and 10. 0.1, when I plug it in, when I plug in the 0.1 right here, and there, that will give me a 10. 0.5, that will give me a 2. A 1, that will give me a 1. A 2, that would give me a 0.5. And a 10, that would give me a 0.1. Okay, so now let's go ahead and draw this picture. So I'm gonna start with 0.1, that gives me like a 10. 0.5, that gives me like a 2. A 1, that gives me a 1. A 2, the 2 gives me a 0.5, so halfway. And then a 10, that gives me a 0.1. You can see a very small. All right, this is the picture of 1 over x. This is the picture of this rational function of 1 over x. This will be the graph. This will always be the graph of the rational function. Now, for the other one, you should actually try the next one. This is an exercise that we do in class. So I really do recommend you guys to try this one. You should actually try this one on your own. Or you can pause the video right now and try it out. Okay, so I'm going to continue because I have to continue with the recording. But if I was a student, I will do what the teacher is telling me. So at this moment, you will pause the video and you will try this problem on your own. All right, so I'm going to continue. I'm going to see that this is a rational function again. And I have a restriction because I have a fraction. Once again, my denominator cannot be equal to 0. So that means that it's going to be similar to the one I already have done in the previous example. Okay, I'm going to select the same numbers that I selected on the other one, maybe negative 10. I'm going to go with the negative 2. I'm going to go with the negative 1. I'm going to go with the negative 0.1. I'm going to skip only 1. And that will tell me, you know, where it's going. Okay, and then we're going to do the graph over here. And this will be like my negative 10 over here. Once again, my pictures are not drawn to scale. If it was like on the board or on a piece of paper, it would be better. Okay, so now I'm gonna plug in the negative 10 into the function. Okay, plug in the negative 10. So then that would be 1 over negative 10 squared. That would be equal to 1 over 100. That would be 0.01. Okay, plug in the negative 2 now. Okay, so then that would be 1 over negative 2 squared. And that would be equal to 1 over 4, which is equal to 0.25. Input the negative 1, that will give me 1 squared, so then that would be 1 over 1, which is 1. And last, go ahead and input the negative 0.1 squared, that will give me 100. And for me, this is enough because I can already see where it's happening. Okay, so this is enough for me. I can actually graph it. So this is negative 10 and 0.01. It's very, very small. And then I gotta go back and plug in the other order pair. So negative 2 and 0.25. Negative 1 and 1. And then negative 0.1 is 100. It's very high up here. There it is. There's the first one. And you can see my restriction is here. Okay, let's go ahead and do the same thing to the other side, which is the right side. So I'm going to go in the opposite direction. So now this is going to be a 0.1, a 1, a 2, and a 10. You can see that I will get the same values. Okay, so now when you do this graph, this will be 0.1 and 100, I think. Give me 1 minute. I copied the wrong digits because I did not plug it in. Let me go ahead and erase what I wrote down. Let me go ahead and go back right here. Okay, a 0.1, it's going to be 100. A 1, it's going to be 1. And a 2, it's going to be 0.25. And then at 10, it's going to be 0.1. This is going to repeat. These values are going to repeat. So now we're going to get it in this other direction here. Okay, this is the graph for 1 over x squared. Now, as you can see that our restriction that for both of these particular functions happen to be x not equal to 0, that's what we call an asymptote. We have a vertical asymptote. The vertical asymptote is what we call the x cannot equal 0. I'm sorry, x equals 0. I gotta put equal to because that's the vertical asymptote. The vertical asymptote is 0, x equals 0. Now we do not cross the y-axis. So in this particular case, it's not letting us know that we have this other asymptote, but we have another asymptote right here since we're not crossing it. Okay. And that is, yeah, that will be y is equal to 0. That will be your asymptote. That will be a horizontal asymptote. But in this case, we're not talking about those asymptotes yet. We will get to discuss these asymptotes at a later time. But right now, just know that those values that you cannot really cross on these graphs are vertical asymptotes at x is equal to 0, and then a horizontal asymptote at y is equal to 0. Okay, let me go ahead and move on to graphing this. Okay, in order for us to be able to do this graph, once again, we're going to do a t-table of values. And you just, have to relax when doing this. Okay, so since we don't know the shape, maybe we can take larger values like a -5. We can do a -1. I can do a 0. I can do a 1. We can do a 5. Now, if it's needed, if I still don't see the shape of the graph, then it will be necessary for us to select more values, more points. Okay, so I'm gonna plug it in. I'm gonna start with a -5 and I'm gonna plug it in here. So this is going to be a -5, absolute value of -5 plus a -5 right here. Absolute value of a -5, it's a 5 plus a -5, that gives me a 0, yeah? Okay, I'm gonna plug in the -1, absolute value of -1 plus a -1. That will be equal to a 1 plus a -1. That's still a 0. Plug in the 0, absolute value of 0 plus 0 will give me 0. Plug in the 1, absolute value of 1 plus 1. Absolute value of 1 is 1 plus 1, that gives me a 2. Plug in the 5, absolute value of 5 plus 5. That should give you a 10. Okay, now I do write too big, but you had to do this on your own, so just make sure you're writing it on paper. Okay, now that I have all of my values, use a ruler, please. A ruler is best. I don't think I can draw on the screen that well, but. Okay, well, that's my rectangular coordinate system. So I have a -5 and 0, -1 and 0. Just think very quickly, if I was to have like a -3 here, -3 plus 3, that would be another 0 here. Okay, so it's like if I have this little piece of the graph just here. Okay, so now 0, 0, 0, 0 is here. So that means that this continues. 1 and 2. X is 1, Y is 2. 5 and 10. Well, I think you can see where it's taking you. It's gonna go like this. Okay, that's it. That's the graph of this function. Okay, let's go ahead and move on to the next part. Okay, the next part that I need to talk about is piecewise defined functions. We have talked about piecewise defined functions in the previous section. We talked about how to evaluate piecewise defined functions, but we really didn't graph them. So today we're going to learn how to graph them. And so let's go ahead and move on to this one. We have two examples. Okay, in class, we did say that the inequalities have a meaning. We have three different pieces of the graphs, okay? And so I'm going to describe them. So I'm gonna start with number one. So I'm gonna separate it. And so then I know that my first piece, it's f of x. It's equal to 3x, but x is less than 0. Less than 0. Okay, I'm gonna start with 0. So this is like my starting point. Just not equal to. Okay, so I'm gonna have a hole on the graph because I don't have an equal sign right there. Okay, so let's go ahead and select things that are less than 0. So that would be 0. I can do a -1. I can do a -3. You can do as many values as you need to. For me, this is enough. So I'm gonna plug it in. I'm gonna start here and I'm gonna plug it into the function. Plug it in, and find those values. Okay, when I plug it in, this will be 3 times 0, that's equal to 0. Plug in the -1, that will give me a -3. Plug in the -3, that will give me a -9. Okay, that's enough. That's all I need. Okay, I'm gonna delete this. Okay, let me go ahead and do my graph. Okay, so I'm gonna do 0 and 0. There's a hole. -1 and -3. -3 and -9. Okay, you can actually see where this is going to go. Let me go ahead and erase that. It's linear right here. It's just a piece of a line. Okay, I want to emphasize at the end point right here, this is like an arrow because I can keep on selecting larger values like a -10 or a -100. So you got to know that it's going to go forever. You can write that down. Okay, let me go ahead and move on to the next piece of this graph. Okay, I'm going to move on to equation 2. And so my equation 2 happens to be f of x. It's equal to x plus 1. And now I got to pay attention to the inequality. Okay, I got to select values between 0 and 2. So 0, 1, and 2, including both of them because they're equal to. Okay, so that's all I need. I just need to include these 3. Let me go ahead and plug it in. Okay, if I plug in the 0 into the graph right here, that's going to be 0 plus 1, it's equal to 1. Plug in now the next value. The next value will be 1. So then that will be 1 plus 1. That will give me a 2. Plug in the 2, 2 plus 1, that will give me a 3. Okay, so then I am ready to plot those points and connect them. So 0 and 1, 0 and 1 is here, and it's a closed circle. 1 and 2. 2 and 3. And you can see that this is a piece of another line. Let's say, okay, let me go ahead and move on to the last piece here. The third one. The third one is f of x is equal to x minus 2 squared. You gotta pay attention to the inequality. X is greater than 2. So 2, 3, and 4. And I gotta start with 2. That's my starting point. And then because it's not equal to, I know that this is going to have a hole on the graph. Okay, so now I'm gonna plug it in. So when I plug it in, I'm gonna plug it in here. So I'm gonna plug it in here. So it's going to be 2 minus 2 squared, that's equal to 0. Plug in the 3. 3 minus 2 squared, well, that will give me a 1 squared. That will give me a 1. Plug in the 4. 4 minus 2 squared. Well, 4 minus 2 is 2 squared. That gives me a 4. Okay, I think that's it. I think I'm ready to plot those. 2 and 0, and there's a hole. 3. 3 and 1. 4 and 4. Once again, my picture is not drawn to scale. Notice that I curved it a little bit. And the reason why I curved it is because I was able to recognize that this is a parabola. And this is the reason why also I would like you guys to recommend to get graph paper. If you do it on graph paper, it's a lot easier to do this particular types of problems than if you do it on a paper like me, okay? Graphing paper really does help, okay? So you don't mess it up. Okay, let me go ahead and move on. I gotta talk about the domain and the range. Okay, so in this particular case, I gotta talk about the domain. Domain, remember, domain is your x's, your x values for the domain, okay? Get a ruler. Okay, now let me go ahead and draw this. Get a ruler, and then what you wanna do is use your ruler. So suppose the green color is my ruler. I can touch the graph. Get a ruler, keep moving the ruler down until you can find a break on the graph. And I come across right here, and I can see that there's a hole, and there's another hole right here. There is a break at 0. So then I'm gonna say that the domain is, wait a second, keep going. That's the only one that I can see. I don't see anything else. So I decided to use the color green to tell you how to do it here. If you use like a ruler. So now that you know that I have a hole at 0, okay, now I'm gonna write it down. So I do have a domain here. You can tell me with words, the domain's all real numbers except for 0. Or you can also write it down from negative infinity. I did not mean to put a comma, I meant to put a negative. To 0. And then union with 0 to infinity. Remember, there's a hole. There's 2 holes, so it breaks the graph, okay? Let's go ahead and move on to the range. Now for the range, you're still going to use your ruler, but now you're going to do it like in a vertical form, okay? So this is I can see the graph is going this way. There's no breaks, there's no breaks. There is a hole right here, but this one, it's on the same place, so it overtakes that hole. So we're okay. Keep going, keep going. This one also here, but it's okay. There's no holes. There has to be a hole in both. Okay, so then for the range, it's all real numbers. If you do it this way, then you will be okay. You just have to be careful not to get it confused. Most of the time, students do struggle with the graphs and so on, but hopefully you guys will be okay. Okay, let's go ahead and do one more. This will be the last one for this section. Okay, so then we have this. Okay, we have two different pieces of the graph. Okay, I have a one piece. And so then I have f of x, it's equal to 0. If the absolute value of x is less than or equal to 2. But what that means, it means that x is between -2 and 2. And so then that will be your inequality. You will do a t-table of values right here. And you're going to select the values that are here. So this will be -2, -1, 0, 1, and 2, and then you will plug it in. Okay. However, where can you plug this in? This is a -2, but where are you going to plug it in here if there's no variable x? So what they're telling you is that your y value is always 0. I don't care what your input is. Your y value here is always 0. That's it. Okay, let's go ahead and do that graph. All right, go ahead and try again. All right. Okay, so this is -2 and 0, -1 and 0, 0 and 0, 1 and 0, 2 and 0. Okay, so then the piece of the graph, it's this one. It includes those points, all of those points, okay? This is the piece of your graph. Do not put arrows in this case because this is a piecewise defined function. Okay, let me go ahead and move on to number 2 right here. That's the other part of my graph. So this says f of x is equal to 3. And then absolute value of x is greater than 2. Well, the absolute value, when is this true? If you think about it very quickly, if I wanted it to test it and I want to know something that it always makes it a true statement, if I plug in a 2.1, absolute value of 2.1 will be greater than 2. A 3 will be greater than 2. A 4 will be greater than 2, and so forth. So x has to be greater than 2. And also, what if I select negative values? So what if I select -2.1? That will still be greater because absolute value of a -2.1, that will be greater than 2. What if I select -3? Absolute value of -3, that will still be greater than 2. So then I had to say that. I had to say x is greater than 2 or x is less than -2. Okay, so let's go ahead and do that. Make a t-table of values. Now try not to get confused right here when you see that less than -2, you're talking about the -3. For example, well, we're going to start with that one. We're going to start with the -2, then the -3, x is -2, x is -3. Let's go ahead and go with x is -5, and I think that will do it for me. So I'm selecting negative values first, okay? Now I'm gonna plug it in there, okay? Now at -2, since it's not equal to, we have a hole also. So there's a hole on the graph right here. Okay, but they always give you a 3. There's no variable, so this is always a 3. Okay, last I gotta do the other one. X is greater than 2, so I'm gonna start with 2, 3, and 5. There's another hole right here. And so this is 3, 3, and 3. Okay, so this is -2 and 3. -2 and 3, and there's a hole. -3 and 3. -5. -5 and 3. So it's like this. There is an arrow in here because they're telling you that x is less than -2. Less than means forever all the way to infinity. Okay, now the other one would be 2 and 3. There's a hole. Then 3 and 3. Last 5 and 3. So you're gonna go this way. All right, that's it. This will be your graph. Let's go ahead and talk about the domain. Well, the domain in this particular case is a little bit harder to be able to draw. I'm sorry, to write, because if I use a ruler for the domain will be fine. The domain will be fine. The domain is this way. Okay, so I have an arrow. There's a hole here, but this one's a closed dot, so it will overtake it. The closed dot will overtake it. Then all this is okay. Okay, all the way to infinity. So that means that it will go from -infinity to infinity. -infinity to infinity. That will be it. That will do it for me. -infinity to infinity. That will be the domain. Let's talk about the range. I think the range is the hardest one to be able to see. You have to switch your ruler around. And so then the lowest point happens to be here at 0. But then you don't go anywhere. From 0, then you kind of jump all the way to 3. And that's it. Okay, so it's that the number 0 and the number 3 that are on your range. You don't have any other values on the y, just 0 and 3. All right. Well, this is it. Have a great day, okay?